will see about lexical to Lex. So Lex is a program that generates lexical analyzer, which is used in the Linux platform. It is mostly used with the YARK parsing generator. You all might be knowing what is the purpose of a lexical analyzer. Lexical analyzer is the one which is going to separate your input string into number of tokens. So Lex is a predefined tool which is available in the Linux-based machine to perform the lexical analyzer work. So it reads the input string and output source code implementing the lexical analyzer in the C programming language. Lex will read patterns, then produces C code for lexical analyzer that stands for identify. So we will just see what is the pattern for any token, how it is. So you have to define a rule for any tokens which have to be identified in the lexical analyzer tool. So for example, I want to identify an identifier. So identifier has a rule that it has to have a letter followed by letter or digit repeated any number of times. So that is the pattern. So this is what it is termed as regular expression, which we have seen in the unit of the previous topic, finite state automata, where you are drawing the finite state automata with all the tokens which you have seen written in the finite state. So this is the pattern. So letter is going to be another token which is going to have alphabets from A to Z in the lowercase as well as in the uppercase character. So this pattern specifies that it is matches a string of characters that begins with a single letter followed by 0 or more letters or digits. So likewise, we can give for all the other token specifications. So what is the structure of a Lex program? We have a definition section followed by the rules section followed by the C code section. So this is what the structure of any Lex program. So when you go for the definition section, it is going to have the header files which we are going to define it, or whichever the terminal symbol, constant symbols, if you want to use it, we'll use it with the definition section. Rule section will be specifying about all the patterns what we have seen in the previous slide. And C code section will call the YY-Lex function, which is a predefined function available in order to perform the lexical analyzer. So we just see an example for Lex program. So this is your definition section where this is your definition section where we are defining the header file. Then in the definition section, we are defining two things, which is nothing but digit 0 to 9 and ID, which is having lowercase or uppercase character. This means that a single character followed by any number of characters or digit repeated. This is what we have seen: letter followed by digit. Letter or digit repeated any number of times. This star repeat specifies any number of times what we have seen in the automata as string closure. Then this is our rules section. In the rules section, what we have is we have, for example, these are all the keywords what we will be using it in our program. So I'm specifying this as keyword. And now this YY-Lex, when we call the program, it will take all the input and it will store in its own variable. So YY-Text is a variable which is going to have the tokens in itself. So ID is nothing but an identifier. So ID is nothing but which is being defined over here with this particular pattern. So this is what. So in similar way, you can write our own options of writing. For example, we may also write plus or minus or star. So I can have this as an operator. Okay. Then YY-Text. So YY-Text will have wait. So this is what. So in this way, we can write our own Lex program. These are all the patterns which you are going to specify. These are all the tokens what we are going to identify. And then we have this main program, which is C subroutine, where you are calling this YY. Here, I'm not giving the input directly to the user by getChar. I'm trying to open a file and writing a C program, and that will be passed, which will be given as an input file to the Lex program, and then it will be executed. So this is how YY Lex program will be done. I hope you all understood. Thank you.